this week's Open Design Learning. This week is going to be on MLIR properties. Um, it's going to be a design discussion. It as Christoph was saying, it was originally it was found out of a discussion on a PR. So the idea is to try to resolve that discussion here. So just to give a bit of background, we're going to start with some background on properties. And before that, it's important to remember what attributes are, which in the case of attributes is just a mechanism to specify constant data in operations. The lifetime is bound to the MLR context, and it endures for the entire duration of the context. They are unique with respect to the context, so you can basically just compare addresses of two attributes and determine if they are the same attribute. And then they are owned by dialects and can be parsed and printed generically and can have interfaces. Now, properties was a response to some of the characteristics of attributes. First, when you have data in a property, you are maybe usually changing it. So it's basically ways to start just changing attributes a lot. And also it proposed like a better way to store information on operations. This is the specification in the line graph. Basically, it is just a way to store extra data members on the operation class. On the right, we have like an example of how to specify a property. They have their summary and description as usual. They have like an optional parser and printer. They are pretty different from the printer and parser that you can.
I will note there's also a parser and optional parsers for parsing in an optional context. Optional parser is the parser when optional.
Yeah. But what I'm saying is, it's all you have all of these fields. But they're very different from what the actual meaning, for example, of a printer or parser actually means in an attribute. And then you have things like convert to attribute and convert from attribute, which is basically a way to specify how to take a property and turn it into an attribute and vice versa. And this is needed for generic parser printing and some other things. And in this case, this is how you specify that you want to use this property, and the storage is an in32. So this is just an example of an operation. It has a unique property, which is basically the same idea of a unique attribute. And right now, you don't have to specify anything. They can all be contained within the attribute.
No, that shouldn't work. That should fail.
No, it works. Oh, well, it could pass.
That should fail because you'd have to say propdict for the property.
Yeah. Ostensibly, this should work.
Okay, it's a bug if that works. Like, that's weird.
No, I think
so. Basically, what's happening is that on the table during specification, you get the storage for the attribute, the storage for the property. In this case, the property is storeable. So you can see that it already has advantages because instead of storing a pointer, you're storing just a boolean with the actual value, and you can notate this more easily. Now, when you generate this, Turtle is also going to generate a bunch of methods. In this case, probably the method that we care more for this discussion is get properties as attribute. There's also similar to set properties from attribute. In this case, the only thing that is being said is sorry is the so this can be used to also there's also methods to set inherit attributes, and in general they will only apply to the actual attributes and not the properties. So this is just to say there's a lot of boilerplate in cases. In some cases, it's not that efficient because you're entering to through a conversion process.
Fabian?
Yeah.
Your audio is really bad, and I really cannot understand what you're saying right now.
Yeah, can you fiddle with your mic again?
Uh,
Like,
Or find a
can you
different.
do a phone you could join in with Zoom or call in?
yeah. Give me. So give me a second.
I don't know if the other on the call can understand or if
No, I was also having a hard time.
yeah.
Okay.
I think we tried to debug this earlier, but yeah.
Okay. It was. Give me a second. It should be.
Also, I have if this I have also prepared some slides that might provide a bit more of an overview of what's going on of properties. If those end up if people want to see those after this.
Yeah, absolutely. I'd love to see your slides.
Just because I think I get the sense that like I get the sense that I at least personally have the thought that sort of skipping through some of the like background information might be helpful here. But that's I mean that
Well, I don't know how long you're gonna need to find another to connect Christoph Fabian, but otherwise maybe Christoph can present in the meantime.
yeah, I guess I could just start talking if that's all right with you.
Give me a second just to.
Okay, sure.
No,
Go ahead.
no, so sure. Well, give me a second.
Oh, sorry. Was I supposed to go ahead, or are we just waiting for audio fixes?
No. For you to go ahead.
Oh, okay. All right. Let me find a screen share button. Excuse me. Let's just think of a present mode. One moment.
So there is Fabian, there is a number you can call with an actually, phone line also if it's better for you, I don't know what are your options, right? There is also the Zoom clients on phone that can sometimes be. I had sometimes to join from my iPhone when my computer was misbehaving.
All right. Where is share? All right. This is going to look. Hold on. Is it share? There we go. All right. I think I get Adobe to fully behave in terms of full screening my. Oh,
It was on Fabian's side because he
okay.
had two devices connected. That's fine.
That makes sense. Anyways, so to just kind of quickly run through a few notes on what's going on here. So,
Can you hear me now? Sorry.
we can hear you now. We can go back
Okay.
to we can go back to you then.
No, go ahead.
Okay. So, I'm just going to like try to not take since we're trying to leave much time for this. Sorry, smoke in the area. But anyways, since we're trying to leave time for discussion and not just present things out too much, I'll kind of move quickly and stop and please stop me with questions. But anyways, we have as of a while, we've got this developing infrastructure for non-attribute properties, which are the ability to put a piece of data, build piece of sort of any, your choice of C++ type theoretically, on directly onto an operations like already existing property struct. They don't get unique to the context the way attributes do. They are mutable. This is still sort of evolving. They're definable in table gen. You have sort of the notion of kind of interface and storage type still, so that like if you're storing a string, you pass in string refs and they get copied, that kind of thing. And we have these things convertible to and from attributes with sort of current code as Fabian was showing. Anyways, to flag a sort of running example of what one might do with these things, like I could have my operation, could have some, let's see, I64 attribute, call it adder, but also could have an id64 property, call it A, and say a string prop B. Then let's just put another integer C and give it a default value of 0. Like this all works today. And part of what that generates is in your adapter for your operation, which then gets inherited by the operation itself, etc. You get a property struct. Like this already happens today. Like theoretically, the TableGen file, like the sort of TableGen program, retains the ability to not generate a property struct and always just store all attributes in a giant attribute dictionary. But I've got an RFC to deprecate that because I don't think anyone's actually using that support for like over a year. But so you get this sort of property struct where like you get an integer adder. I think as Fabian's code example shows the like complexity, it's slightly more complicated in reality, but presentations. And you get getters and setters for all these things. Like you'll notice, for example, the that string there has storage type std string, but you get and set it as a string ref, for example. Like that's already a capability we have. And as I mentioned, like anything that kind of upstream generate, like all of the dialects use property structs, even if they don't use any non-attribute properties. And similarly, this is something that got added last year, or over the course of the last year or so. We have a builder. When you have these properties, you actually get builders where you can pass in your int64s and your string refs and so on. And there's also the somewhat generic form where you pass in the property struct. One of the sort of infrastructure notes that I'll get to in a few slides is that this generic builder here is not really implemented in a suitably efficient way because we still scan this thing called discardable adders for anything that might be an inherent attribute, because the code to not do that hasn't been written yet. And just to give some notes on like how this stuff also works with parsing and printing these days, like if we have your op in fully generic form, where I left off a right angle bracket, unfortunately, you get, you basically convert all the property struct via, get properties adder, as Fabian was showing on his slides. You convert it to an attribute, in this case, like a dictionary attribute, and you just print that. If you actually fully write out, like an assembly syntax, you assemble together all the relevant attribute or property parsers printers. You can similarly do sort of optional stuff with that C where you leave off the default value. And also, if you call for this propdict thing, what that does these days is it'll just do the same thing that the generic format does, serialize all the inherent attributes and properties that you don't otherwise mention into a dictionary like this and just print that out. I have one of my like RFC items is that it probably should look like this instead, where we don't serialize to an attribute and we just do effectively like a struct of these things. I hope I'm making some kind of sense.
One of the
Here's some kind of
one note. The reason
go
why
ahead.
there are braces is because it's called propdict. It's a key value pair things, and so I think I reuse the syntax of the dictionary here.
But the thing is, propdict literally does print out a dictionary adder.
Sorry, what?
Propdict, as currently implemented, uses a dictionary attribute to print.
Yeah, that's why it's using this syntax, right? It's like it's
Right. No, that's fair.
representing the fact that you also
Yeah,
write.
but the like I'm proposing like breaking syntax changes, so I'm trying to actually break the syntax so it becomes
No, but when you say it should be, like I'm saying like why it's not. And so when you say it should be, you have to explain why it should be. Like it's a
so
dictionary, but you don't want to
well,
put it as a
I mean,
dictionary.
it's not necessary. So it's actually not the angle bracket, the curly brackets I'm concerned about.
Okay.
What I actually want, fundamentally, what I want to do is if I'm doing a prop dict, that should sort of generate
Oh, it's
parsing,
types. I see.
like you don't have to
Okay.
print
You have a type
basically
switch.
you're not printing the types because you're not using a generic serialization. You're not
Okay.
converting to an attribute. You actually go through your property struct, you look at each field, and you generate a parser or a printer for that field. And you
That
can
makes
put those in any order. And like the lack of curly braces is just to break syntax so that you have something different when you're doing it the new way.
that
I'm
makes total sense. I totally anchored on the wrong thing on the slide. Yeah.
No, that's
That,
that's no, that's a fair question, and like I think that's something that I'm not like I can understand. Like fortunately, there's not a lot of adoption of non-attribute properties or prop dict, so we're probably still in a position where we can make this kind of breaking change without upsetting too many people. But it is a breaking change that I do actually want people's opinions on, even if it's not necessarily the full topic of this meeting. Anyways, I should probably hurry it up. Anyways, this slide is basically just actually putting in words more or less what I've just said. Because I fiddled with my slides at the last minute. Uh, anyways, just a few notes on bits of infrastructure I think are missing. Uh, and the details of this, I think Emily and I we've been hashing this out in a discourse thread, and probably can keep hashing out there because I think you've made some very good points. But fundamentally, the mechanism for creating uh, operations doesn't have a way to say, hey, I'm keeping my like inherent attributes and non-attribute properties and my discardable attributes completely separate. And so like you always have to do a bunch of logic to try and like reconcile the fact that you might have something inherent in the list of attributes. So like things like clone get less efficient and so on and so forth, even though, or if you were doing like a prop dict, adder dict split, you'd still walk through that adder dict to look for potential like inherent values. And we like in the future, we would want to not do this, but we don't really have a like we just the little tiny it's a small matter of programming just to actually add support for that. But that's like one of the sort of remaining notes I have. Uh, as I mentioned, I had sort of thoughts on the prop dict directive, which is that you could instead of just serializing to an attribute and printing that, you could actually sort of walk your property struct and be like, okay, it has like these fields, here's their printers, we'll just print them in some order, and then we'll parse them in any order they could appear in, and so on and so forth. Uh, I think we could, if we drop the curly brace and kind of use more like the sort of struct syntax you see on like custom defined attributes, then you can even do this in a somewhat backwards compatible way where if you see, you optionally parse a dictionary adder first, so that this also makes it easier to like copy paste from the generic form, that kind of in most circumstances. But that's details that I think they might be off topic for this meeting actually. Um, then there's the thing that Fabi and I were arguing about, which is whether we want to, or one of the things that's been actually argued about, which is whether we want to extend set inherent adder and get inherent adder to also allow you to get and set the non-attribute properties using their attribute conversion code. So like we have the ability to kind of handle an entire batch of properties, for the generic parsing and printing, but we can't go one at a time. And I mean, this has the advantage that you can actually write reasonably generic code by targeting a string, and might make it easier to generate FFI bindings. It has the disadvantage that this results in things getting serialized to attributes that we were trying to not have serialized to attributes because that's kind of a waste of time. and maybe people shouldn't be using a method like this is, I think, also a very reasonable objection to adding something like this. But it's at least worth considering. And I think there's the bigger issue, which ran into, like, I was actually trying to I just kind of, when I was doing some stuff with like the AMD GPU dialect, I just used some non-attribute properties in a few spots where they made sense because, hey, it'll work. And then we ran into some folks who were trying to use the operations in Python, and none of this was hooked up. So there's sort of a bigger question about how to expose non-attribute properties in FFI bindings, partly because non-attribute properties are sort of inherently just a member in a struct in C++, which can make it a little bit unclear how to unlike attributes where you've got this like generic class and everything's sort of abstracted out into the LVM like dynamic, you get like dincast and things like this. You don't currently get these of non-attribute properties. I believe, to like roughly summarize, Fabian thinks eventually you should. I don't think you should. I'm of the opinion that most of the things people are storing in a non-attribute property are going to be like relatively small, straightforward data types, such that you can, the translation to, your C or your Python is relatively mechanical. Like you could auto-generate it, especially if you sort of did a little bit, like basically stood up like a little mapping of, C++, like C++'s string ref is a C string ref. And, if you have an array, you just need two members, you could, for the common case, handle this pretty well. And, oh, sorry, Fabian had to give your hand up.
Yeah, maybe let me present what I think are the issues and then we can debate because
That's fair. Yeah, I think I have, yeah, I don't really have, okay, this is just more, yeah. I think that's sort of me pointing out everything that I wanted to point out, which is that I think there are some bigger issues that Fabian was trying to bring up. And so having kind of taken a tour down everything I've said over the past couple of weeks, I'll pass the floor because I think I've basically made my point about what's going on. All right, go ahead.
okay. So yeah. Can you hear me well?
Yep.
Okay. So for me, there are several issues. The first one is they broke C and Python bindings. And so I also have some issues that for me, they are just C++ implementation details of operations. And then later, this will become more clear to what I'm meaning. So, and the reason that in the end, this is all troublesome is that we are relying on attributes to just interact with everything else, which is also inefficient. And there's also some other things that could be great to have, like no interfaces, like having interfaces. So to say what I mean with properties are just simply plus implementations, details of data, and that we need to resolve this on the line graph. So the first thing that I would like to do is change the definition of the properties in the line graph. If you see currently in the line graph, sorry. Oh.
We already have verifiers, by the way. Like that's already a thing.
No. The one thing that if you see on the line graph, they basically say they are stored directly on operation class. So it implies too many details about C++. So if we want to solve,
I strongly disagree.
Could you let me?
We'll finish.
Yeah.
Yeah.
If you so there's too many details here, interfaces, accessors, and other methods. So the first thing that I would like on just a pure semantical basis is it's just a mechanism to specify arbitrary data. Let's remove the idea that they need to be serialized to an attribute. That shouldn't be on the lang graph. That is a detail on our implementation or a constraint on our implementation. So that is just the first change that I would like to see. Then there's some other things that I would like. First, removing the idea that we need to round trip through attributes. I think this was a temporary measure. Mary can correct this. So there's also there's some verification mechanisms for properties, but we need to strengthen them to make way to be able to generically parse and print attributes.
And I don't think we need to be able to do any of that. That's what I said.
Yeah, I'm proposing, Chris.
Yeah.
So basically, the idea of why I think that we need this is because the main issue, the main problem with properties and attributes right now on, let's say, Python, is that if you don't have a Python binding for an attribute, you can parse data. You cannot do that with a property. So you are effectively at a loss there. The one way to solve that, I'm not saying it's the only way, it's to have the ability to generically parse and print properties. That would also solve the generic parsing and printing issue of operations because we wouldn't need that anymore. And the idea of having verifiers is that one of the things that attributes do is to verify on construction. And just assert to avoid any issues on generic parsing and printing. Then the way to do this is this is our details, like, for example, having like a new unique property storage just to store unknown properties or generic properties. The properties inside and up would remain the same. This is just a mechanism to interact with them. Same thing with the unpacked property graph or a prop graph that is a concrete class of them. If we implement all of this, basically, there's no reason anymore to have attributes be convertible to properties. We would be solving the C and Python binding issues, or not solving, but we would provide a remedy. And as a nice benefit, we could end up allowing property interfaces. One thing that I would like is, again, remove round tripping, but make all attributes convertible to properties. This last bit should be straightforward because we already have the storage class for attributes, not the other way around. So I would also like to clarify what is our guideline in the lang graph or on the MLIR docs about when to use attributes and when to use properties. This is my proposal. Basically, just if data rarely changes, if you need fast comparison, or if you need the data to persist for the entire duration of the context, use attributes. Otherwise, please use properties. Once we have all the changes necessary upstream, we should use these guidelines to update all the dialects. And as some optional changes, I would like to remove the discardable attribute dictionary and use just a map of properties holding attributes, just to have like a more consistent view on the operation. Obviously, that would need to be back with actual performance data to see if it's less or more performant than having an attribute there. But would also solve some of the other issues. And yeah, the last one is just my wish list, but it's barely related, and it's because their interaction with props is limited. So yeah, let's open the floor for discussion.
So I'm just going to start by saying I think like sort of
Were you seeing my screen?
yeah, I'm seeing your screen.
No, before.
Sorry. What about your screen before?
Were you seeing my screen here?
Yeah, yes, I'm seeing your screen.
No, before.
So before what?
We saw your screen during your presentation. We saw all your slides.
Yes.
Okay.
Yeah, no. Anyways, the thing I'd like to do is I basically this I really don't think this proposal is the direction we want to go. Like this is turning properties into attributes, and properties and attributes have from my point of view, they have very distinct sort of purposes and rather distinct use cases. Like
How is it turning them into attributes?
because you're adding like a generic support, you're adding even discardability. Like from where I'm standing, the general use case of a non-attribute property is like data that is associated with operation, constants and tags you're sticking on an operation. Like, your like unit attributes where it's just like a flag or, an integer, I don't know, alignment or something, or, linOg generics, like array of, these like small bits of data that don't need to have these like long lifetimes, that don't need to live in a context, that don't need to go through all this process. Like
It wouldn't have in this on
no, but
this proposal.
that is the purpose of a non-attribute property is to be this kind of tag you hang off an operation. Whereas if you're using an attribute for something, even if it's inherent, like you're using it often because you want a certain amount of genericness. Like if you're feeling the urge
But
to
that
have
is a constraint that we have right now.
no, but like I think
It
that is
doesn't
an
have to
important
be.
constraint. Yeah, but I think it should be that way, which is that like
So I'll just point to the original RFC. The original RFC, it's actually even mentioned that interfaces could come in the future.
yeah, but I from where I'm standing, I don't think property interfaces make sense.
Why not?
Because like if you're at the point where you're adding an interface and you're basically leaving the set of concrete things you could put in the spot open to arbitrary modification, then you're not at the point where you could just like stash like a piece of plain old copyable mutable data into a struct hiding on an operation. Like you are now building a whole class of things, and like something like LLVM, like data layer, like the whole like DLTI stuff, like that doesn't make sense as properties because that's this, you don't know how much room that's going to take up. You don't know it's big, it's long lived. It probably does make sense to be unique, and you're often sticking it in a discardable dictionary in the first place. Like
yeah, but you don't need that. Like you can have all of that with a reference. That is
yeah, but
what
like
I'm saying.
no, but like if you're but that's we already have a mechanism for this. It's called attributes, and having
But attributes serve as very different. That is why I'm also saying that we should specify when attributes should be needed,
and
because
and like similarly,
the queues of interfaces, it's not really of or genericity of interfaces just applying to attributes. It's just a constraint on our implementation. There's nothing fundamental on them.
Yeah, but if we're going to sort of maintain the status quo, which I think is a pretty good status quo of properties are tags that hang off of operations in our, relatively straightforward
That
scalars,
wouldn't
small arrays, that kind of thing, then we like, what kind of interfaces do you think we would actually want?
First of all, that wouldn't change. Like properties would remain basically the same. The only thing that
Well, no, they
is
wouldn't. You're
in
adding all
property-
this like referencing stuff and like maps, and
no,
you're adding all this
like,
stuff to them.
so the only thing that is like this proposal is trying to make that is like a large breaking change is removing the need to round trip through attributes. That is
No, I'm hearing a lot more because like, how does this work with an I64 prop just being an id64 on an operation? Like, I don't see that continuing in your world.
it's still there. You don't need like the property storage is not going to change. If it,
Okay,
for example,
I
if
don't
I
understand
told
your
you,
proposal then.
hey,
Like,
no, if I
then what's all
told you,
this
hey,
generic stuff? Like, that's what changed to property storage.
no, you don't need. So an interface it's stored in the MLIR context, not on the
Yeah, but like,
or in the cases of operations on the name. But what I mean is it's not necessarily stored within the property. Even I'm not saying add a type ID to a property. I'm not saying any of that.
well, I mean, I don't understand how you could implement it otherwise. Like,
No, I mean, if I can chime in, like, I don't think there is any implementation difficulty here, right? The only thing that we have with what you call generic printing and parsing means just having a mnemonic, right? We need the parser to be able to call back into what is already the property printing and parsing code, right? So
Yeah.
if a property has a printing and parsing function, then the
yeah,
only
sure
thing
it does. Yeah.
that the mnemonic dispatch there, right?
I
Then you
mean,
need
okay, yeah,
some sort of
you could do that. Yes.
then
Like,
you need some sort of mechanism for alloc.
registering these. Yeah.
Yeah, right? It's like now you need some sort of a shared pointer or unique pointer storage, like because you need to carry it around from the parser down to the operation constructor, something like
Yeah.
that.
Yeah. Now you're doing all this interaction and genericness, and how do we even know how many bytes we need for this? That feels really at odds with it's a field in a struct.
We already have
We are
that.
already doing that for
The fact that
attributes.
operation state can construct properties means that we
Well, no,
already
no,
have.
I mean, an operation constraint can call a no argument constructor that allocates a blob of plain old data. Like, that's very limited functionality for a reason.
Because that is implementation, not because
No, because
there's
I think that's
something
actually like,
inherent.
I think that's actually a good way to limit ourselves from like weird nonsense.
But actually, we are doing, in my opinion, we're doing more weird nonsense by having round tripping things through attributes.
Well, I mean, like that's why I'm more thinking like custom assembly syntax, to minimize the amount of round tripping, but like the fact that you need to round trip to this generic thing, which is an attribute to print generically, is not a flaw in the system.
It's a constraint that made, well, I'll let Mary
I mean, maybe I'm like wrong, but
say why it
or
was
like
needed.
maybe you have some third opinion here, but I think the fact that like, okay, I mean, I guess I could like, I guess like in principle, the idea of doing like property mnemonics, like, I guess you could make it work, but and like maybe that's even a maybe that's even an interesting direction, and like you could make it work, and if you like really did some clever stuff with like pointers and you know void star and all that kind of stuff, like
As
I
far as
guess
you know, this is the only thing that you need. Like, it's not even that much.
no, yeah, but like the thing is, if you're doing mnemonics, you need to be able to dispatch to them,
Yeah,
which
but
means
I
like
I've seen the parser. This shouldn't be hard.
I mean, this sounds like there's it still sounds like there's like type IDs involved.
Could you just repeat that? I couldn't hear you.
like it sounds like there's type IDs and
Oh, yeah,
you know,
but you
a
need to
property
store the type
hierarchy.
ID in the property.
Like it sounds like we're doing a prop hierarchy and we're sort of getting away from
No, you don't need
sticks
to
of,
store the type ID in the property.
well, you got it. I mean, where else are you gonna put the type ID for 864 key?
So for C++, you can just say specify that just use the declare type ID stuff. And when you call the type ID on int64, it's going to return something. So you don't need to, the reason that you need to store the type ID inside something is if you want to pass that exact object. The type ID would be stored on the opaque property ref or the property ref template
Yeah.
or the unique property storage.
Like I'm not sure I understand what this like unique property storage and property ref even are.
So basically that is that in that specific place, you would be adding the type ID to have all the genericity. So the property storage and the properties wouldn't change. The only thing is that with these classes, you could interact with them in a generic way.
Like I basically like no, that's fair. What my okay, so right. I just don't understand really why you would need to go through all this trouble. Like
Because we broke
we have
the
attributes.
C bindings and the Python bindings.
You could generate
now-
C and Python bindings.
Huh?
Like TableGen exists for a reason.
TableGen is not magic. TableGen cannot interact. There's
Well,
a
you
reason
could
why.
you could define mappings between C++ types and types in your language.
Hey, Christoph, I have a question. Like, why are you so anchored on attributes? Like, why is it good that we serialize property to attribute instead of not, for example?
This is like basically like the trouble I'm seeing is like it feels like having the ability to like having a prop what I would think of as like a prop hierarchy, and it almost feels like we're proposing the ability to do
I
ISA
don't see-
on a property and things
First
like
off-
this.
Christoph, what hierarchy?
Like if you can, like if you have this kind of unique prop storage that you could dimcast an ISA on it, no?
Not necessarily.
I mean, okay, because like that just seems sort of inherent in the proposal here.
No.
That you'd be able to like
Like
do LVM type dispatch on these things.
Think about how operation states work. It can store an opaque property right now.
That stores a void pointer.
Yeah, exactly. So you don't have dimcast.
Yeah, that's fair. You just have to know what's going on. Yeah. I mean, like, basically, what I'm seeing is like the amount of sort of like, especially in other parts that like in later in the slides where there were like a bunch of stuff around like discardability. Like, I'm seeing that we're sort of reinventing, or like even the notion of like a prop interface. Like, it feels like we're sort of reinventing the genericness of attributes, which doesn't really fit with this is data that sort of meaningfully belongs to a specific operation and hangs off that operation as a function of what that operation means.
I don't quite understand why you make a distinction between like some data that is specific to an operation and attributes, right? A lot of attributes are
Right.
exactly the same.
Right, but there are
Exactly.
the use that there if we're trying to sort of break apart two things, there's the use case for properties, which is one of the main uses of attributes of just sort of, hey, I've got this like small bit of data I need to hang off this operation because like it's got some constant or some flag or things like this. And there's the other like usage of attributes you often see frequently where it's like, hey, here's like my configuration attribute for my compilation. It hangs in a dictionary off of like a Linux generic or a function or a module. Like here's this like big object, or here's a data layout spec. Like these are these sort of bigger, more generic objects that often don't end up inherent to operation definitions, and or even if they do, like you sort of do want to be treating them as these, or heck, even in the case of like actual like IR level constants, you don't want to be, it's hard to define a way to store like any possible value of a riff.constant in line. Because like it could be, you can't even really use AP float for it because people might have weird custom float types. So
Sorry,
like there is a valid use case
I didn't catch
for
the last part. Why can't you use AP float?
Because I don't want to lock us into AP float. I'm a strong advocate of generic float or like generic scalars actually, because the ability to store any bag of bytes as a constant and like because of the the arbitrary scalar types are FC basically.
But
I'm
you're
still-
losing me about your train of thoughts. Like, how does this relate to the difference between
or
properties?
like vectors or things like this. Like basically, if you're defining a property and an attribute, you're talking about a fixed size concrete thing, and usually small, or like fixed, like sort of fixed representation concrete object, of an array of values of this particular enum, an integer, a unit flag, and if you're using an attribute for something instead, you're being much more open about what you can put there.
Well, how so? Like, unless you're using attribute interfaces, you're as much concrete as a property.
Well, no, like even like integer adder, or like if I just go inter float adder, like if I have if I have that thing that you often see where you're like need to stick a constant on something, it's like any integer or float, like how does that translate into a property?
It's sorry, to me, it's exactly the same. Like if you think about attributes, they have a storage. The storage is exactly a C++ struct. Like
Yeah,
the
but
only difference, like,
but you're storing a pointer.
Sorry,
And
let me finish.
go ahead.
The only difference to me that a constraint that an attribute has that a property doesn't is that the attribute has to be able to generate a hash key and be unique in the context. Right?
Yeah, whereas
the property,
I think that the fact that when you're using an attribute, you're storing a pointer into a context, and you're sort of being
doesn't matter. For interfloat, it doesn't matter. I can write std optional AP float AP int.
I mean, if you want to write that, like, yeah, if you want to do like a tagged union of ints and floats, I guess you can. But like but like my claim is that especially once you get to the point of like vector constants or like that kind of thing, which you often, I think that is like a decently common use case when you're dealing in constants, a vector, a float, a vector of ints, a vector of floats, any, take your pick. Like at that point, trying to cram all that in line into your operation is actually bad for performance and not a good idea. And so we want to use the existing separate mechanism of attributes.
I don't agree. You're missing the point. Like std vector is not as much in line as an attribute. It's like two pointers, right?
Just because it's there. Let's give time to Jack to maybe he was trying to say
that's right.
something.
You've been trying to say something for a while.
I didn't see it.
No, but I think my comment was going to be on the generic printing and parsing type. So if we want to continue with this discussion, I can get back to that later.
Oh yeah, no, I mean, actually, yeah, go ahead, go to the generic and parsing and printing because like there might actually be something useful there.
No, I mean, like, I think that we're sort of doing a differentiation here, where we're trying to say like we want generic printing to be and parsing to be fast. Where I don't care about the generic printing parsing. We have specialized forms of printing and parsing. So if you're generating bytecode, you know what you're printing. You're generating the optimized form. If you want to back generate to an older variant, generating the attributes are actually quite useful. So I think the ability to be able to round trip through this form for the generic printing and parsing is actually quite useful. And I don't see the efficiency of generic printing to be important. I see for that we have specialized forms, right? Like there's no reason if you're printing bytecode to print the attribute form. You don't have to. That's already true. So this is purely for I think for like different toolings and parsing. So we lose Python, you lose your reducer, you lose your Haskell bindings, all the other language bindings, all the generic tools you can build. They're all gone at this point. If you have no way of doing it, and everything becomes dedicated parsing, which I don't see much benefit to making that part good, right? For me, the being able to generate an attribute.
You're losing me. What do you mean make this part good? It's like what is good and not good in
So make printing the generic format fast.
so
It's
here,
not a-
here I think the point here is not to make it fast or not, right? And the slide probably doesn't convey the points very well. I would not have called it generic parsing. I would have called it context-free parsing. Today you cannot parse a property, like the property parser cannot be invoked outside of an op.
Because
Compared to-
properties are attached to operations and are functions, properties
Sure.
are part of operations.
There is no fundamental way for this, and that's what
Yeah.
Fabian is. And so what it would
And
allow,
I mean, I
we're
guess
doing.
maybe you could. I just don't think there's much of a
Christoph,
reason
I'm
to.
talking, so if you could just not interrupt me, it would be great.
Sorry.
What it would allow here is what people are using attributes for today, context-free parsing of attributes is within Python bindings. When you don't have Python bindings to attributes, you can just give a string, parse it, get back an opaque thing. You cannot do anything with it except use it in the constructor of an operation then. And this is what I think Fabian is trying to also enable with this, like by putting this context-free parsing on the same level as the context-free parsing that exists on attribute. Not that we ever parse attribute in a context-free way. Like an attribute is never not attached to an operation either. Yet we can have context-free parsing.
Well, I mean, the mnemonics at the top of the file.
Sorry, what?
Like when you do like the thing of find maps at the top of a file, I'm pretty sure that's parsed independently of an operation.
That's parsed independently of an operation. That doesn't
Yeah.
exist in the IR independently of an operation.
Yeah, that's true. I'm just thinking like you're like map 1, map 2 kind of thing.
Yeah,
I
that's crazy.
believe
Yes.
in our bytecode parsing we do, because if we have an opaque attribute in a string, we parse the attribute table first before parsing the operation. The table of attributes are created beforehand.
Yes, what I'm saying is they don't exist in the IR. Like you can write it, you can parse your file.
Mhm.
If it's not attached to an operation, it's discarded. It's like it doesn't exist.
Except for an alias.
Except for
Alias. You
which
can have, well,
is attached to an operation, right?
no. Well, type alias, you have the attribute in the type. So it's just alias, there's no operation yet.
Sure. So both attributes and types, they only exist to the point where they are attached to an operation. Otherwise, they will exist during the lifetime of the parser, get linked in the context, but you never get a handle to it. If you parse an input IR and what you get back is a block of operations when you call the generic parser, always. And any attributes or type that is not attached to an operation or to the block, I don't know if you can attach it to the block itself, maybe a block argument, will be lost. You cannot get it.
Good question. I don't know if they're still in the context or not. If you have an alias that's not actually utilized in the block that you're parsing, the alias is parsed before registry operations, and I think it gets unique in the context.
Yeah.
But I mean, it's not attached. I mean, I think we're perhaps saying different things about attached, because that attribute's lifetime is now the duration of that context, but it's not in any op.
Yes, but you as a user don't know it exists. You don't have a handle
Correct.
to it, access it.
Correct.
You cannot rate attributes in the context.
I think that's a slightly off topic. But
Well, we're
yeah,
talking,
I mean, all right. I think
Mm-hmm.
okay. I think now that I'm sort of getting a clearer handle on what's going on here and like why we're talking about this, like the having sort of registered parsers and printers for property values, so that you could do kind of, as you said, like kind of generic FFI stuff where it's just a string. Yeah, I think that actually might not be a bad idea. We might want to go that way. I could, like, I don't think there's actually. I think now that we're sort of, now that I've sort of hashed out a lot of, now that we've sort of hashed out a lot of what the sort of implementation details I was inferring from all this, like, I could see it. I don't think I did. I don't think the no op on release mode on like property verifiers makes sense though. But I can at least agree with, okay, properties maybe become like an independent thing. I think the question is like, you don't really have dialects associated with properties.
You don't
So it's
need
kind of hard to know when to register them.
So it's the same thing that if you try to register an operation to that already exists within a dialect, you're just going to get an assert. And
Right.
in this case, you can, for example, this is if you want to scope your name, we can just say we're going to use something like C++ namespaces to just scope them. It's all going to be part of the string, and it's just going to say, hey, this is how you
Yeah.
want to do it, but there's no need for have them in a dialect. So again, all of these
Well,
changes, none of them affect how the underlying properties act. It just enables
yeah. Like, I
things.
mean, aside from the like minor detail of who sets up the parsing hook for I-32, and like because the way sort of a lot of this currently works is like you have to, because everyone sort of has their own copy of int32 prop, it's becomes thoroughly not obvious, what
No,
you're having
so
to like include. But that's details and probably is actually fixable.
okay, but again, I would say that the most important change is amending the definition on the land
Yeah.
graph.
And I like the thing is, I do want to keep a lot of the sort of facts about properties, which is that they are these often small
That's
data
not going to
members that live
change.
in line on operations. Like, I think that's an important aspect of a property.
Yeah, that is not going to change.
Like, because a lot of the sort of like tail end of your proposal really did feel like you were trying to produce these like really generic mechanisms for
The,
working with an arbitrary piece of data.
yes, but you don't need to change like the existing property storage in an operation to accomplish all of that.
Yeah, I mean, all right, fair. I guess if you just like rearrange like how the like constraints get generated and how parsing and print actually like pull out parsing and printing into its own function, which probably means you have to move a lot of the like integer and string props into like the built-in dialect, so they're only defined once.
they don't need to be
Well,
in a
no, but the
dialog.
problem is you have to define them exactly once. 'Cause otherwise, there's like multiple different instances of the parser for int32.
Yes, but that we just simply say if this is the thing I32, we are registering it on the directly on the ASM parser just as a default part of MLIR, and that is it. If you want something different with your int32 property, define it with another mnemonic.
Yeah, no, basically, I'm just sort of raising the implementation point that because properties don't have associated dialects, if you want to reuse one of these things in multiple different dialects, it becomes because like they don't have a sort of natural home the way they're currently implemented. It's not really clear like who does the registering. Like that's obviously fixable. I just wanted to like flag this issue.
Yeah, those are details. Important details, but those are details.
Yeah. No, I mean, yeah, I think I'm at least coming around to, the notion of uh a of generic parsing and printing hooks, just so you can kind of smuggle non-attribute properties across F5 without having to really do much. Yeah, I think I see what you're trying to get at, and I think it makes sense. And therefore, I think I can also at least get behind, you know, okay, we can have uh the what I'm my sort of mental image of this prop ref thing right now is a string, a type ID, and a void pointer, or like a unique pointer to, who knows what, where so you can just stuff your parsed data, your like generic, your sort of unknown value into this little box, and then there's a method on operations that looks at the box and puts the value in the right field in the struct. I think I think I'm now understanding your proposal a bit more, and I think that makes sense.
Okay, any other comments?
Like, I mean, that is basically what you were thinking for like prop ref, right? Like string type ID and pointer to question mark.
Like for the prof ref, it's basically just saying each C++ class will get assigned not inside the class a type ID, and we can use that and put it inside the pack prof ref so we know what is inside.
Right, that's fair. Like, actually, one thing I don't understand. Well, what's the purpose of unique prop storage?
That is in case, for example, when you do need to parse generically and you don't have an operation, you could use that to hold your property. It would be a pointer to a C++ class internally, and you could use that to then initialize a C++ uh, uh, thing from C or from Python. So that is just another implementation detail.
I just like, I mean, I think I'd have to see like some actual like definitions of these various things because I don't like. There's a version of what you're proposing that makes sense to me, and there's a version of what you're proposing that feels like you're sort of reinventing a lot of the overheads associated with attributes, and like, and in a way that we're trying to avoid. I thought, and I don't fully understand which is which at this point.
So unique here, unique doesn't mean unique in the sense of attribute. I understand it more as unique pointer.
Yeah,
yeah, okay, it's unique pointer to something. Yeah, it's okay. That I can agree with, yeah.
Better name like owning prop, or something like that. Owning
Yeah. Right. The point being that after you parse this generic thing, yeah, okay. You need to put it somewhere, and we actually might want a class for that. Yeah, okay. That's fair.
Until it's at an operation, someone needs to release the memory because we need malloc, because we don't know the size ahead of time, etc. It's all
exactly. No, but that tracks. And then a prop ref holds one of these things, and probably a type ID and like a name, maybe actually.
We are much over time. That we table this to next week. Something
I don't think I can make next week, unfortunately, but
okay.
2 weeks.
We can do next week and in 2 weeks and every week until we have a plan. I'll try to start a Google Doc with the list of action items and share it with you guys and on the forum.
Yeah.
And we can basically make
I think this was a good discussion, and I think I'm at least. I think. Yeah, I mean, obviously, I think the details. I think at this point, at least now I understand the proposal enough that I'm like, okay, I think we can work out the details, and I don't think this is actually like sort of fundamentally a bad idea. So,
fantastic.
I mean, I'm not sure about some of these optional steps here, but other than that, I think I'm now getting what the plan is, and it's actually, I think I kind of like the plan. So, yay, productive meeting.
Can you send me the slides, both of you? So.
Oh yeah, sure. I'll send you slides. What's a good way to send you the slides, actually?
Either on Discord or by email if you have my email.
Yeah, I'll just attach them to Discord. Cool.
Thank you.
Thank you all for coming. I'm gonna stop the recording.
Yeah, thanks everyone for coming.